In this video, we are discussing similar triangles. And when we say similar triangles, we are talking about equiangular triangles. What do we mean by the word equiangular? We mean that their angles are equal. We mean two or more triangles that have equal interior angles. When we look at these two triangles that we have in this diagram, we could see that by the diagram that angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. So we can say that these two triangles are similar triangles. Not minding, obviously, when you look at the diagram, you could see that this is bigger, like the sides are kind of bigger than this, but provided they have their angles equal, that is when we say they are equiangular. That is, that this one is an enlargement of this particular triangle. And now we have what we call corresponding sides. Like this side AB is corresponding to side XY. And if we look closely at the sides, we could see this is the side that is between these two angles. Yes, as this angle is equal to this angle and this is equal to this angle. Therefore, this side between the two angles is corresponding to this side that is between these two angles. Therefore, side AC is equal to side XZ and side BC is equal to side YZ. So that is what we call corresponding sides of similar triangles. Now, these two triangles that we have here, they are aligned, like they are similar and they are just aligned, like this angle to this angle, we could see them. Now, let's look at what if we have angles that are turned upside down, turned like similar triangles that are turned in different ways. How can we still recognize their corresponding sides? Now we can see we have these two triangles. This is quite bigger than this. Then let's look at their angles. Remember we said similar triangles are equiangular triangles. We could see 109, we could see 109. We can see 22, we can see angle 22, and therefore 49, 49. Now just two angles are enough to show us equiangular triangles, because the sum of angles in every triangle is equal to 180 degrees. Therefore, if let's say we are just shown 109, 49, 109, 49, we will also know that this is equal to this automatically, because they must all be equal to 180 degrees, like their sum. Okay. Now, we have that we want to learn how to name equiangular triangles. So let's start from the first diagram. We can just say XYZ, that this is triangle XYZ, and that will be all. Now, in order to name this one so that they could correspond, what we are going to do is, since we said XY, and that is for this side between angle 22 and angle 109, we'll come here and then also name it. Between angle 22 and angle 109, we have ML, just in that order. So we have triangle ML, and therefore the remaining one N. So do you see how to name it? Don't worry, examples will also show us, like other examples we're going to solve will help us to understand what we mean by naming the similar triangles in a corresponding manner. And now it is very, very important that we name them correspondingly, because it's going to help us to solve. Since we say that similar triangles are like an enlargement or a reduction of the previous shape, so it's going to help us to actually solve for. Now let's use an example. Let's say that this side is 10 cm in length and that this side is 4 cm in length and that this side is 12 cm in length, and then here is 6 cm. And we are told to calculate for this side. Let's name here A and let's name here B. So we are to calculate for the third sides A and B for this one. So how do we go about that? What we are going to do is, now having named our triangles correspondingly, what we are going to do is we are going to start from this side we know, which is side xy. So we are going to say that xy over this side that we know, which is yz, is equal to, now since we said xy, if we are to name a side correspondingly, we have to say ml. Did you see it? Xy ml. So ml from this side. Then we said yz, that means ln. So now let's get the equivalent sides now. So xy is equal to A, then yz is 4 cm, which is equal to ml. ml is 12, and then ln is 6. So we cross multiply. And when we do that, we are going to see that we have 6a is equal to 12 times 4. We divide both sides by 6. And when we do that, we are going to see 2 times 4, which is 8. So we have that side A is equal to 8 cm. Therefore, A is equal to 8 cm. Now, remaining side B. Now, for side B, we just go by, we start from what we are looking for. Like, that's where I like to start solving anything I'm doing. So, I have side MN, that's MN, the side B we are interested in, MN over any other side. So the side I'm going to choose, maybe let me choose the shorter side, ln is equal to, since we said mn, we are going to come here to say xz over ln, therefore we say yz. So you always name them correspondingly. Now, having named them correspondingly and then just using the names, the way we named them, the manner in which we named them, we see that we don't have to bother our head to find out, okay, this side corresponds to this side corresponds. We just look at the letters and then get our values directly from them. And then forget about the hassle and bustle of trying to make sure that we are looking at corresponding side from the diagram. Like, that will be a stress. So we have side MN is equal to this B over LN, which is 6, is equal to side XZ is 10 and YZ is 4. We cross multiply. We have that 4b is equal to 6 times 10. And we divide both sides by 4. So that 2 here is 2, 2 here is 3, 2 here is 1, 2 here is 5. So 3 times 5 is 15. We have that side B is equal to 15. Therefore, B is equal to 15 cm. So we can see how easy it is to solve. Now let's solve more examples so as to understand better. Now for the second example that we have here, we have this triangle. So in this triangle, we could see it's made up of this big triangle and then this small one that's inside of it. And now let's see. We can see that this angle is equal to this angle. And both of the triangles, the big one and the small one, they share this corner, this angle. And remember we said that once two triangles have two equal angles, therefore the third ones are equal. Because the sum of angles in a triangle is equal to 180 degrees. So if two are already equal, that means the third one is also equal. So these two triangles, the big one and this smaller one we could see inside here, are similar triangles. Okay, so the first thing we do with similar triangles is to name them accordingly. So let's start with the big one. We could see that the big one we could name alphabetically. So PQR. So we say that this big angle PQR is similar to or equivalent to. Now let's be careful to name the smaller one. We said PQ, meaning this angle not shown is corresponding to this angle not shown. That is equal to this angle not shown. So that was where we started from. This angle not shown to this angle that they share. So we have to say this angle not shown to this angle that they share. So SQ, and of course the third letter R. So which corresponds to this other angle that was shown. So corresponding to T, which is this other angle that was shown. So we have named them correspondingly. So now that we've named them correspondingly. Okay, remember our question is even asking us that side SR is equal to what? So we are to look for this side. SR is equal to what? So let's just name that SRX. Now we've done the major work of naming the two triangles we have correspondingly, which is very, very important. So now we are going to, of course, like I do, I like to start from the side that I'm looking for. So I could say QR, side QR, which involves what we to look for. So I could say side QR over. Now I now mention this other side that we know its value, which is PQ. Side QR over side PQ is equal to, now that I've named from what I'm looking for, now let's now duplicate the corresponding sides. So we said QR, did you see it's QR? Therefore, what did I say? SQR, please, it's SQT. Oh, my bad. So SQT, that is SQT, please. So we have QR, therefore QT. QT over, we said PQ, so PQ, that means we are talking about SQ, SQ accordingly. So now equivalently, that's the value QR is equal to 5 plus X, or we could just say, let it just still remain QR, then when we find the length, we take away 5 from it. Or what do you think? So let me still leave it as QR. Over PQ, that is 6 plus 6, which is 12, is equal to QT. QT is 6. And then SQ is 5. Okay, remember we just cross multiply. You see how easy it could be to solve? When we cross multiply, we have that 5QR is equal to 12 times 6. We divide both sides by 5. But we have that QR is equal to 12 times 6. That should be 72 over 5, which is equal to, so we have that QR is equal to 5 into 7 is 1, remainder 2. 5 into 22 is 4, remainder 2. Point, okay, 4 again. So 14.4 cm. Remember that we said that QR, that's the whole length. So the side we are looking for, which is SR, therefore SR is equal to 14.4. That's the whole length minus this given one minus 5, which is equal to 14 minus 5 is 9. So we have that SR is equal to 9.5. 9.5 cm. You see how easy it is to do? Okay, let's do one more. Now for the next example, we have this shape, this diagram, forget about proportionality, but by the diagram, this angle is equal to this angle. And when we look at the big triangle and we look at the small triangle, we notice that they share this same angle. So having two angles already equal, that means these third angles are also equal. So forget about how the shape looks like. Forget the proportionality of the actual diagram. We just use the information we know to solve in this diagram. Okay, so we've been asked for this length of ZQ, of this line Z to Q. What is it? So that is what we've been asked for. Okay, so let's name that place. Let's name it something like, do I name it A or B or C or D? Let me name it side F. Yeah, it's a letter not usually used. So let me just name this side F. So ZQ is what we are looking for, F. Now, the first thing we do is to name the two similar triangles accordingly. So let me start with the big one. I like starting with the big one. Okay, so the external triangle, we could have it as BQX or XPQ. Let me just say XPQ. Let's find the equivalent accordingly. So we said XP. So we started from this side they share to this angle given. So we start from this side they share to the angle given. So XZ, XZ, and then the third letter for the small triangle is Y. So we have named it accordingly. So I believe by now, when you see any equivalent triangle, you can name them accordingly. Very, very easy thing to do, but that's one of the most vital things to do before solving similar triangles. Okay, so now, like I said, I like starting with the side that contains what I'm looking for. So we have XQ, XQ, so that when we get it, we this one is not complete, so we have that here is 10 cm. So when we get this side XQ, we subtract this 10 from it to find what ZQ is. So XQ over this side, we know this side, XP, is equal to, now since we've named XQ, XQ, therefore XY, XY over XP, so XZ. You see how easy it is to work with. Okay, now we are going to replace with numbers. XQ, I could just leave it as XQ or 10 plus F, 10 plus the letter F over XP, XP, 9 plus 3 is 12, is equal to XY is 9, and then XZ, XZ is 10. We cross multiply. And when we do that, we are going to have that 10 into 10 plus F is equal to 9 times 12. And we divide both sides by 10. So 9 times 12 is 108. So let me have that here. 108 over 10 is equal to 10 plus F. Okay, so that we have that 10 plus F is equal to 10.8. That's when we divide by 10. 10.8. So, and then from here we have that F is equal to 10.8 minus 10. Therefore, F is equal to 0.8 cm. So, since F is 0.8, therefore, remember we were told to look for ZQ. Therefore, ZQ, which is equal to F, is 0.8 cm. So, arriving at where we started from, 0.8 cm. Now, lastly, let's look at this last example. Now we have the triangle PQR and also PHK. Now we have parallel lines here. Now for triangles like this, we can see they share this angle, right? Both of the triangles, the big one and the small one, they share this angle. And then because of these parallel lines, therefore, this angle here is equal to this angle here. And if we look at it, this is a transversal of the parallel line. So they are corresponding angles. And then for this side too, we could see they are also corresponding angles because this is another transversal and they are corresponding. So this one, when we name them PQR, we also name PHK. So for the two angles we have, triangle PQR is similar to PHK. Okay, and then for the question says, what is the ratio of KR to PR? Ratio of KR to PR. Now, we know that all these things, they go according to same ratios. So very, very easy. We are going to be using this side that we know. So KR, that is KR, will be corresponding to HQ. So we have that HQ over, or let me start with what we are given. So I start with KR over PR is equal to, so KR is corresponding to HQ. And then PR is corresponding to PQ. Now let's use numbers. HQ is 3. PQ is 3 plus 4, which is 7. So the ratio of KR to PR is 3:7. As simple as that. I hope you learned something.